Alright, here we are starting a simple linear programming model using Google OAuth in Java. First thing we do is load the native libraries. Here you can see this part. And without design, the Solver backend won't run properly, so we always include it at the beginning. And this gives us access to all the Solver functionality in the OAuth package. Right after that, we create a Solver instance itself. Okay, and we are using GLOB here, which is Google's linear programming solver, and it is designed to solve problems that only have continuous variables, so no integers or binaries here. If we wanted to deal with integer variables, we would use something like a CBC instead. That's okay. And then we define two variables, x and y, as you can see here. Let me switch. Both are continuous and constrained to be greater than or equal to 0. In this syntax, 0 is the lower bound and the upper bound is set to positive infinity, which just means there is no upper limit. So basically we are saying x and y can take any non-negative value. Next up is a linear constraint. We are building the first one here. It is written as x plus 2y and less than 14. To represent that, we use make constraints and give it a lower bound of negative infinity, which just means we don't care about any lower restriction for this constraint, and an upper bound of 14. Then we assign the coefficients 1 for x and 2 for y. That matches the expression we want to enforce. So at this stage we have loaded the solver, defined the decision variables, and introduced one constraint and two limit their values based on a linear relationship. And let's move on and add the second constraint to the model. And what is that? This one is written as 3x minus y is greater than or equal to 0. You can see here. And that's basically saying the value of 3 times x has to be at least as big as y. To define that in code, we use make constraint again, but this time, instead of setting the lower bound to negative infinity like we did before, we set it to 0. And that reflects the greater than or equal to part. The upper bound is still positive infinity, so there is no upper limit. After that, we assign the coefficients, what is that? 3 for x and minus 1 for y, which matches the expression exactly. Okay, that's done. Alright, once both constraints are in place, we define objective function. The goal here is to maximize the expression 3x plus 4y. So we first get the objective object, then set the coefficients 3 for x and 4 for y. And we explicitly tell solver that this is a maximization problem using a set maximization. Okay, and finally we solve the model. We call the solve method and then we check the result status. If the solver finds an optimal solution, we print the values of x and y and also the value of the objective function with those values plugged in. Otherwise, we just print out a warning that no optimal solution could be found. So, to sum it up, this little program defines a linear optimization problem, sets up two constraints and an objective, and then solves it using the GLOB solver. And the solution gives us the values for x and y that maximize the expression 3x plus 4y while still respecting both of the constraints we have defined. And this was the linear programming example Java file. And let's look at our POM XML file. And Maven setup and done to get all 12 OAuth working properly in this project. And at the top of the POM XML, we have got the basic structure of a Maven project, version info group and artifact ID, and then under properties we are setting the Java compile level to version 21. That part just tells Maven which Java version to use when compiling to code. So it is saying use Java 21 both as source and target. Next comes the repository section. OAuth is not always available on Maven Central, so we point Maven to Google's own repository, and without this the dependencies we add below would not be found. Then in dependencies block, and what are they? Let's look. We bring in the libraries we need from OAuth. The first one is OAuth Java, and that's the core library that includes all the logic and solvers APIs. The version used here is 9.6 and 25.34. Right after that, there is another dependency for OAuth Linux x86 and 64, which is the native binding needed to run the solver on a Linux machine. If this was running on Windows or Mac, we would include the respective native libraries for those platforms instead. That's okay. So this setup makes sure both the Java interface and the native solvers included the build. That's what allows the program to call load native libraries and actually link to the backend solver when it runs. And if you forgot to include the native dependency for your platform, your code will compile but crash at runtime because the solver engine won't be available. And let's look at our output after run it here. Okay, so the solver ran successfully and returned an optimal solution. According to the result, x is 14 and y is 0. That means to get the highest value of the objective function under the given constraints, the best choice is set to x to 14 and y to 0. The objective function we defined was 3x plus 4y. Plugging in the values we got, it becomes 3 times 14, which is 42, and since y is 0, that term drops out. So the optimal objective value is 42, and that's exactly what we see printed here. And below that, we see the line that says process finished with exit code 0. That just means the program ran without any errors. If there was a problem with the setup, like a missing native library or bad constraint definition, you will see a different exit code or an exception instead. So yes, this confirms the model was correctly built, solved, and interpreted. The result makes sense. It is respecting to constraints and maximizing the objective as expected. And if you ever get the unexpected results, you might want to double check the constraint definitions and make sure the solver type matches your problem type, especially if you are working with integers or binaries.